Hi, good morning. Okay, looks like there's no one else joining in. Let's see. Okay, so I'll continue with the ASA part. Okay, just did a very brief overview yesterday. Okay, understood how we do the bootstrapping and everything. Okay, how the default traffic works, how do you put your static route and everything. Okay, just a very basic configuration to get your traffic flow going. So today, so yesterday I told you about the security level here. Okay, very important part from the perspective of ASA. It actually helps the ASA figure out whether the flow is inbound or outbound. For example, let's just okay. So if the ASA has to figure out, or if it's outbound flow, it would basically mean the traffic is going from a high security level to a low security level. Okay, which would kind of like be here in our case. Okay, so when this guy tries to access something on the internet, okay, he will be going from this inside interface to this outside. Okay, so inside has a security level of 100, outside has a security level of 0. So that's basically going from high to low. Okay, so that's your outbound. If you do it vice versa, that is basically your inbound flow. We write that out. That would be low SL to high SL. Okay, that's one part of the security level. Now, the other thing is, by default, this traffic is allowed. As long as you have the correct NAT in place, as long as you have the correct routing in place, okay, the outbound traffic is allowed by default. You don't really have to create any additional policies, any access control, any entries, etc. Okay, just works. This is also relevant, or this part only applies to TCP and UDP traffic. Okay, so all TCP and UDP connections that are flowing outbound, which basically means from high SL to low SL, they are allowed by default without any access control policies or any additional config in place. Okay, this is not allowed by default, inbound flow. Okay, in order to allow inbound traffic, you need some sort of an inbound policy or incoming policy, or some sort of a policy in place to allow inbound traffic, okay, which will be any traffic that is flowing from low SL to high SL. Okay, that's really how ASA handles traffic flow. Okay, and that's what governs whether you need additional config to allow traffic, what all you might need, might not need, etc. Okay. Now you can have multiple interfaces have the same security level. Okay, so two interfaces cannot have the same name. Okay, I cannot have two interfaces named as outside. Okay, I cannot have two interfaces named as inside, because like I said yesterday, anytime you reference any policy, any config within an ASA, it references the interface name rather than the interface. So if you have multiple interfaces with the same name, you cannot really create differentiated policies. Okay, from the ASA's perspective, it won't really be able to figure out which interface it should really need to point that config for. Okay, if multiple interfaces will have the same name. So interface name needs to be unique across the config, but the security level can be the same for two or more interfaces. Okay, let me write that here as well. Can have the same SL. Now the catch to this is, if two interfaces have the same security level, traffic is not allowed to flow between them. Okay. So if two interfaces have the same security level, there can be no traffic flowing. Now there can be two things to it. Okay, and it cannot be allowed to flow, not even with an ACL. Just right, not even with a policy. Okay, there can be two use cases for this. Multiple interfaces can have the same SL. Okay, one of them could be something like a hairpin of traffic. Okay, so maybe traffic coming into this interface and then going out of this interface as well. Okay, so traffic is coming in on gig 0/1. It has security level 100. It's exiting out of security level 100 interface, which is that same interface as well, right? Not allowed. Okay, this basically would be an intra interface. Okay, another one could be, let's say we give the DMZ interface here a security level of 100. So the users here, they won't be able to access anything in the DMZ because both of these interfaces will have the same security level. Okay, this would be inter-interface traffic. But let's just call it inter. Okay, so intra is going to be hairpin. Or sometimes you might also have it called as U-turn traffic. Okay, it's not allowed by default, even with a policy. Okay, you can change this behavior, but the change is globally. Okay, you cannot do this change on a per interface basis. Okay, so there are caveats to using that, obviously. Okay, if you are kind of like in an MSSP kind of an environment, okay, you're providing security services to a customer. A couple of customers request this feature. Okay, maybe they have their partners and everything off of you as the same MSSP, and then they want to allow that traffic. You won't be able to do it selectively for just a couple of customers or just a couple of interfaces or just a couple of networks. Okay, whether you do it for everyone or you don't do it at all. Okay, and the global command to enable this is same security traffic permit. Okay, and then you can put in whether you want it to be interface or you want it intra interface. You want to enable it for intra or for int. Okay, so that's the behavior for security level. Okay, high SL to low SL, it's allowed TCP UDP only. Remember this, okay? If you have non-TCP UDP traffic, for example, something like ICMP, that's not allowed, even outbound, okay? And we'll go over it when we'll talk about some of the more traffic, how the transit traffic and everything works, okay? And I'll go over the details. How do you fix those problems and everything, okay? But again, a lot of these things have been done because even though the ASA kind of behaves and looks very similar to a Cisco router, but it is a security device. Okay, so it does a lot of things that a Cisco router does, but it also is a security device. So there are lots of restrictions as well. Okay, that's the security level concept. Now, from the perspective of doing deployment, okay, specifically from the perspective of interface. Okay, so when you are purchasing something like, or when you have something like ASA, you don't have unlimited interfaces. Okay, depending upon what sort of a platform you have, okay, you can have limited number of interfaces. And if you are going to use one interface for maybe configuring one subnet or one network, okay, you're going to quickly run out of interfaces, which typically is not kind of like a good design in itself. Okay, when you can do a lot of different ways in which you can provide redundancy. Okay, very important. Okay, and in some cases you can even increase the aggregate throughput and the bandwidth for your traffic. So when we talk about interface deployment, one is the very basic one, which you see here. Okay, one interface connected to one part of the network or one subnet. Okay, this would be the very basic one. Okay, obviously not too popular. Okay, and like I said, some models might not even have sufficient interfaces available for you to achieve this. Okay, so in this you'll have your ASA, let's suppose. Okay, one interface. It's connected here. Let's just connect router here. Okay, on the router here. Okay, so this is, for example, 0/0 port. It's going to be 0/1 port. Okay, that's a very basic deployment. Okay, dual home, triple home. I already explained that yesterday. Okay. Instead of this, a very popular thing is to use sub-interfaces. Okay. Basically, you just have a single physical interface connected, and the link between the ASA and the switch will become basically a trunk. Okay, so you have ASA here, right? It's connected to, let's say we have a switch here. Okay, and then you can have multiple networks hanging off of here. Okay, so this link here, a very basic routing switching concept. This is a trunk. Your ASA acts like a router on a stick. Okay, so you do sub interfaces just like you do it on a router, basically. Okay, so config for this would look something like, let's say this is the gig 0/1 interface. Okay, so very first thing is obviously you need to have the physical interface unshut, and then you can go ahead and you can create your sub interfaces. Okay, let's say I have one VLAN 100. Okay, maybe you then configure the .1q tag. Okay, this is irrelevant. The .100 is just a naming convention, but whenever I'm trying to do configurations, I kind of try to match it with whatever VLAN is going to be referenced by that sub interface. Okay, kind of helps when you're trying to review the configuration and everything. Okay, apart from this, rest of the configuration remains the same. You would be configuring IP address, you would be giving it name, and you would be also giving it a security level. So all of the concepts that we saw previously, all of them apply. Okay, but now you really are utilizing one physical interface to connect basically a bunch of different subnets or areas of the network. Okay, the problem to this is there's no redundancy. Okay, so here you still have that single point of failure. Okay, so being quite popular, but no redundancy. Okay, another option here to make use of redundant interfaces or redundant interface, for example. Okay, so your ASA, it is physically connected to two different switches. Okay, so we have ASA here. Okay, so we connect this to, so let's say switch 1. Okay, so one interface here, and then another physical interface basically connects to a completely different switch. Okay, now there are a couple of problems to this. The redundancy is really only handled by the ASA. These two switches, they're not communicating with each other. Okay, and these interfaces, they are in an active standby state. Okay, so only one interface, it remains active at any given point of time. Okay, so for that reason, not too popular, right? Because even though we are utilizing two physical interfaces, one of them will still be unused. And if you're in a very stable network environment where you do not have a lot of outages and everything, okay, you might never utilize this interface. So really just wasting on the resource. Okay, but still, in some deployments, in some places, you might still find use for this. Okay, and the way that you do the config, so we have these two interfaces, 0/0, and then let's say this is 0/1. Okay, so again, the physical interfaces, you unshut them. Okay, and then you create a redundant interface. So I'll just name it interface red 1. Okay, and both of these interfaces, they become members of this redundant interface. So member interface gig 0/0 and member interface gig 0/1. The rest of the configuration remains the same. Given my IP address, name the interface, also configure the security level. Okay. A much more popular option is to make use of port channels. Okay, from the switches perspective, we call them Ethernet, Ether channels, not Ethernet. Okay, Ether channels. Some of the devices, they still call it Ether channels. Routers, firewalls, typically call them port channels. Okay, so you can also call them aggregate links. Okay, one and the same thing. So this is a much more popular option to configure. Okay, because you are bundling multiple interface into one logical interface. Okay, so you have active across all the interfaces that are part of that bundle. Okay, so you are not plaguing it with the active standby scenario here. Okay, all the interfaces are used. There's inherent load balancing there. Okay, and you also have increased throughput. Okay, and in this case, if so your ASA is connected to, let's say, multiple switches typically. Okay, and the two switches can be connected to talk to each other as well. Okay, so and you can do this if you have a lot of budget. Okay, and if you are using Cisco Nexus, right? You could make use of virtual port channel, VPC, and if you have the traditional Catalyst devices, right? Let's say 4500s or 6500s, you can make use of VSS. Okay. A much cheaper option is to just take two switches and use a stacking cable, right? That is going to be the most cheapest option. Okay, so you'll have your ASA here. That case, okay, and so you have the stack here. Okay, so interface here is going to connect to switch 1. So interface here is going to connect to switch 2. Okay, and this is basically stacked here. Okay, from the ASA's perspective, these interfaces, they will basically form your port channel. Okay, so from the configuration perspective, again, we're taking the same interfaces, 0, 0, and 0, 1. Okay, so the physical interfaces will be unshut and they will be put into channel groups. Okay, so we want to make both of these interfaces part of the same port channel. So we're going to put them into same channel group. Let's just say channel group 1 and on. Similarly, you'll do this for the gig 0/1 as well. Unshut it. Put it into the same channel group or port channel. Okay. Once you have done this, okay, once you have configured the interfaces for these channel group, a new interface will be available for configuration. Okay, and that will be port channel 1 interface. And the config really remains the same. You configure the IP address, nameif, security level. Okay. You could also have multiple interfaces to each switch. Okay, so you can have something like 2 interfaces here connected to switch 1. Okay, 2 interfaces connected to switch 2. You can have something like this as well. Okay, and you can have this single port channel, but then you can split it into sub interfaces. Okay, this is kind of like the most popular way of doing things. Okay, so for example, in this case, you can sub interface this here. Okay, so you can do something like where this becomes interface port channel 1, 10, VLAN. Okay, And rest of that, it remains the same: IP address, name if, and security level. Okay. The interface 1 to 20, VLAN 20, and the rest of things same: IP address, name if, security level. Okay, so a most popular option, typically in a data center kind of an environment deployments. Okay. Now this is for the perspective of interfaces, right? When you talk about from the actual physical appliance perspective, okay, obviously you would always want to have multiple devices, okay, or multiple ASA appliances, okay, physical appliances, okay, connected because you want to have redundancy. Okay, so if we talk about, let's say, from a DC deployment perspective, okay, you can have 2 ASAs connected to each other. Okay, to provide an active standby scenario. Okay, this becomes your failover link, which is a link through which it exchanges the configuration, etc., etc. Okay, we'll discuss this when we will look at the failover part. Okay, this is an active standby. One behaves as active device, which takes the traffic. The standby is just monitoring the active. Okay, if the active fails or the health of the primary or the active ASA is poor, then the standby promotes itself to be the active. Okay. A second option is to do active-active, which is typically done through clustering. Okay, so you have, or you can have up to 16 ASAs connected together. To form a single logical device. And the good thing about ASA clustering is all the devices or all the firewalls are active in a cluster. Okay, so they do load balancing, load sharing, all of that good stuff. Okay, and these ASAs, they're connected through something that we call as cluster control link, CCL. Okay, so we'll look at this when we'll do the labs and everything. Okay, so that's really your different types of ways in which the interfaces on the ASA can be deployed. Okay, a lot of this will carry forward into the next generation firewall piece. Okay, that's why I'm covering this part here. Okay, because I won't cover this again on the next generation firewall. Okay, so a lot of this is the same. There are a couple of things which would be different that we will discuss when that part comes. Okay, that's the interface and the couple of high availability failover kind of scenarios in which you can have the ASA deployed. Okay. Now, talking about how the ASA handles traffic. Okay. Let's say we have ASA here. Okay. And let's just put in DMZ as well. Okay, so triple home kind of a setup. Okay. Now, already told you about the TCP and UDP. Okay, so TCP UDP traffic into out allowed by default. You don't really need to do anything. Okay. What about something like ICMP? Okay, something as basic as a ping, right? And it's important in production networks, even though it has its inherent issues. Okay, a lot of time it's blocked across the environment. Okay, but it's still necessary to have it for troubleshooting purposes. Okay, it's one of those very basic troubleshooting tools. Okay, so from the perspective of the ASA, you have two types of traffic. Okay, one is to traffic. When I say to traffic is the traffic that is meant for the ASA, okay, or that is destined for the ASA. Okay, one of the ASA's interface. Okay, very common examples for this could be something like ICMP, Telnet, SSH, maybe even HTTP, HTTPS, when we're trying to access the web page for the ASA or for ASDM. Okay, this is to traffic that is destined for the ASA. Okay, now talking about ICMP or ping, this user can ping only its closest interface. Okay, and I'm only talking about to traffic. Okay, ICMP from this user can work to this inside interface. ICMP from this user to this outside interface is not allowed. There's no way to change this behavior. Okay, so ASA is pingable or reachable only on the closest interface, closest to the source. Okay, now this behavior is different than a router. So on a router, if you have something like loopback interfaces, they are pingable, they are reachable as long as the underlying routing allows for it. Okay, but since ASA is again like a security device, there are inherent security measures present in it. Okay, I do not want someone on the sitting on the internet to ping my inside interface. Okay, it can help with, or it can help the attackers, hackers with doing kind of like a network discovery kind of thing. Okay, they might try to figure out what my network infrastructure really looks like. Okay, there's no way to change this behavior. Okay, this is working as designed. Okay, now similarly from this DMZ here, if one of these servers they try to reach this inside interface, they can, no problem, but they won't be able to ping again this outside interface. Same thing from the outside. The closest interface to the source is reachable, not the interface further down. Okay, that is my to traffic. Okay, another thing about to traffic is you cannot control the to traffic through access policies. Now I'll just write ACL. Okay, if you have to control to traffic, one of these entities, let me just call them, okay, you have to use the relevant service. For example, Telnet is a service. So you cannot do something like deny TCP, etc., or deny IP, etc., and then put in an EQ of 23 and expect it to block that. It won't be able to do that. Okay, so the two traffic can only be controlled with the relevant service that you're trying to use. So you can control who telnets, who SSHs, who does ICMP, who cannot. Okay, but it is done through the relevant service config. Okay, and we'll go over those. I'll show you how that is done. Okay, that's my that's really my two traffic. Okay. Now, how do you do some of these two traffic based configurations? So let's just say, for example, Telnet. Okay. In global config, you do something like Telnet. Okay, and you then put in the network. Okay, so for example, I want everyone to be able to do Telnet. This is equivalent to like in any state, catch all. Okay, so Telnet this, and then you give it an interface name. So this enables Telnet on the inside interface, and anyone can Telnet. That's what this really implies. Okay, so you are configuring it through the service. If you only want to allow, let's say, your IT network or IT subnet to be able to telnet into the ASA, that's a network that you configure here. Okay, so you're making use of the actual service rather than using an ACL to control two traffic. Similarly, you have SSH. Okay, with SSH, there are a couple of additional things. Okay, because you need to have credentials configured as well. And you can configure the ASA to either look for the credentials locally, or you can also configure it to check for the configurations against a radius server. Okay, so it's the same way. You have the service, so you do SSH, whatever network needs to be, and then where do you want to enable it, or on what interface. Similar to this. Additionally, you would also want to configure some sort of a credential. Let's say I want to use a local database. Okay, so just say username, admin, password, say 123. Obviously, not really and not secure enough for production. And then you configure the authentication, AAA authentication, SSH console, and local. Okay, so this local keyword here, this is what tells it to use a local database. And this is case sensitive. Okay, instead, you can put in like radius, you configure radius server config, and then the ASA can send out the requests to the ASA. Sorry, to a radius server. Okay, so you can use it for TACACS as well. Okay, but here we are doing authentication for SSH. Okay, one other thing to note about ASA is you cannot use an ASA as a transit for Telnet and SSH. What I mean by that is you cannot Telnet an SSH or SSH into an ASA box and then use the ASA to Telnet and SSH into any other device. Okay, so ASA does not work as a Telnet or an SSH client. It is only a server. okay, which is very different than, again, from a router. Okay, so you cannot use the ASA to jump to any other device. Same principle, it's basically a security device. Now, these are two of the ways in which you can do management for the ASA, telnet and SH. There's a third way, which is through HTTP, HTTPS. Okay, this is where you have ASDM, Adaptive Security Device Management or Manager. Okay, it's basically a Java-based application, and it is a web-based or a Java-based GUI for ASA administration. Okay, so if you don't want to use a CLI, you can use ASDM to do your configuration. Okay, it uses HTTPS. So when we do the configuration, you will see I am enabling HTTP, but it actually uses HTTPS. Okay, and it's the same way. You again control it through service, which is HTTP. Okay, so you do HTTP server enable. Okay, and then you configure who would you want to allow that HTTP access, right? So maybe I only want to allow my IT network to be able to access. And then you obviously have to tell the interface as well. Okay, so even if this command says HTTP, okay, the ASDM is going to be using HTTPS. Okay, so don't get confused by that when you implement it and you don't configure HTTPS, but it still use HTTPS, so it will use HTTPS. Okay. Last part of this is to actually configure or tell the ASA where that ASDM image is. Okay, so this ASDM kind of does not come along with ASA. Okay, if you're talking about a virtual ASA, then yes, it comes as part of it. You don't really have to put in anything additional. But if you're talking from an appliance perspective, a physical hardware appliance, you would need to upload this ASA image, sorry, the ASDM image from Cisco. Okay, and it's available on CCO or the Cisco software download center. Okay, and you typically would place it either in the flash or disk 0. Okay, so you need to tell in the config where that ASDM image is. Okay, so you do it with ASDM image, and then you put in the path. Okay, so for example, let's say if you placed it in the disk 0 here. Okay, so you're gonna put in the name, whatever the name is, and this file will end in .bin. Okay, so it's a .bin file. Okay, so once you have this config here, that's basically it. That's basically the ASDM config. Okay, you can then connect, open up whatever the IP address is here that's inside interface. Okay, open up in the browser, HTTPS, that IP address, and it will give you a couple of options. It can ask you, or if you don't have ASDM already installed, it will give you two options, whether you want to run it in kind of like a Java web-based applications where you don't have to download any additional software and install it. The other option would be to download a piece of software, which is the actual IDM, okay, or the actual manager, which is like an application. Okay, you can download it, install it, and then use it. Okay, so when we'll do the lab, I'll show you how to enable it and how it kind of looks like. Okay, so these are your management, and then I already talked about the ICMP part. there is another option for you to do management. So these three options, they are in-band management. ASAs, they come with a dedicated management interface as well. Okay, this is an out-of-band management. Okay, there is a dedicated management interface. Okay, and it's just interface management 0/0. Okay, this interface is unique in a way that it has an additional command that's configured on it. Management only. Okay, with this command, or this command can be configured on any other interface as well. You can configure on the outside, you can configure on the inside, you can configure on any interface. If you configure the management only command, that interface will only then be able to do to traffic. Okay, it will not be able to do what we call as transit traffic. Okay, which I'll talk about next. So transit traffic is traffic that is flowing through that interface. Okay, to traffic is traffic that's meant for that interface itself or destined for that interface itself. Okay, so this command really configures or takes away the ability for the interface to handle transit traffic. Okay, the interface then only becomes a to traffic interface. Okay, so you have a dedicated management interface. Okay, so you can enable Telnet SH HTTP HTTPS on the management interface only and just manage, and that's really the purpose of it, to help you manage. Okay, the rest of these interfaces can just be for handling your data traffic, okay, for transit traffic. And apart from this management only command, there's nothing else that's different. Okay, you would still configure your IP address. You would still have nameif. You would still have security level. Okay, this is the only difference here. The management only command. Okay, that's a to traffic. Now let's look at the other side of things, which is your transit traffic. Now, transit traffic is the traffic that is flowing through the ASA. Just make a new one here. Okay, this guy trying to, let's say, access ebay.com. Okay, the traffic is going through the ASA. Okay, this is transit traffic. Transit traffic can be controlled, or the only way to control transit traffic is through ACL. Okay, which is different than to traffic, which cannot be controlled through ACL. So if I want to control who accesses my network or my internet, I can configure an ACL, define a deny statement. Okay, who I want from the outside to be able to access, let's say, my DMZ resources, I configure an ACL to either do a permit or a deny. Okay, explicit configuration. Okay, now from the ASA's perspective, I said that all TCP UDP allowed by default. Okay, which basically also means that only TCP UDP traffic is inspected by default. No additional configuration required. Okay. And for now, just understand when we say inspection, it basically means that we are creating state table entries. Okay. Something like ICMP is not inspected by default, which basically means no state entries are created. Again, this is for transit. Okay. For example, this guy, he tries to ping ebay.com. Okay. Now the problem that happens with this, okay, it is non-TCP UDP. It won't be inspected. There'll be no state table entries. This user will not receive any responses to the ping, which does not mean that there's a reachability problem. Okay, is the way that the ASA is by default. Okay, so what happens in this case is this user, he will send ICMP echo request. Okay, since it's not inspected, ASA will forward the request, obviously. Right? Why? Because traffic is flowing from high SL to low SL. It's allowed by default. No need for access list configuration. ASA will forward the request. No state entry, no state table. Okay. eBay.com will send a echo reply. Now what happens? There are no state table entries. What does the ASA do? ASA checks existing connection. Consults with state table. No entries. Check ACL. Right now, when we're talking about only the defaults, there's no ACL configured. Right? What happens? So drop. Okay, so the pings are being sent out from the ASA, but the return traffic is what is being denied by the ASA. Okay, that's the default behavior. Couple of ways to fix it is you either enable inspection for ICMP as well. Okay. When you enable ICMP inspection, the state table entries will be created for ICMP traffic as well. Okay, this is I mean, it really depends, okay, whether you want to use it or not. Okay, I've seen customers use it. I've not seen customers use it as well. In my opinion, a much better option is to create explicit ACL if you want to allow ICMP. Okay, it's a much better option. You have much more control over what you are allowing. Okay, so on the outside interface, you're going to create an ACL, okay, which will say, hey, we are allowing ACL. So even when there'll be no entries, when the ACL check will be done, check against the ACL. Okay, so understand this, that with ICMP or without the ICMP inspection enabled by default, the ASA is working as a stateless firewall for ICMP. Okay, so you would need to explicitly configure ACL entries if you want to permit that traffic. Okay. Now, from production perspective, there's a little trick, command, and everything. So when we talk about the two traffic here, specifically the ICMP, okay, I told you that two traffic is allowed. The two ICMP it's basically because of a hidden command, okay, which basically says ICMP permit any and whatever the interface is. Let's say, for example, outside. This is a hidden command, okay, because of which the traffic or the ICMP to the ACA is allowed, not ACA, AS, sorry. Okay, you can block this as well. So, for example, let's say in production, what you want to do is, I want to be able to send ICMP out, but I don't want to allow anyone to ping my outside interface. Again, making it more secure or hardening the appliance or the device. Okay, so for that, what can be done is you can do ICMP. Again, this is two traffic. That's why you cannot do an ACL. That's why I'm using this ICMP service. Okay, so ICMP permit any echo reply outside. So this command, it overrides this hidden command. Okay, and this command now it's going to block all ICMP echo requests on the outside interface, but will still allow ICMP to go out. Okay, so this interface will allow echo replies come in. But if there are any echo requests that are seen coming into that interface, okay, or destined for that interface, it will basically block it. Okay, kind of like a very real world kind of a strat. Okay, just a way to harden the device. Okay, so I don't want anyone on the outside interface, from the ISP side, from the internet, to figure out or maybe ping or run any sort of ICMP against my outside interface. But I still want to be able to send ICMP out and receive echo replies, but I don't want to receive echo requests. That's what the command is meant to do. Okay. Now, ASA, from a routing perspective, it supports all of your major routing protocols, dynamic routing protocols. Okay, so there is support for EIGRP, RIP, OSPF, BGP, and even ISIs. Okay, and we'll implement one of these protocols in the lab. It's very similar to how you do on a router. Okay, so nothing much to do there. One thing which is again different from a router is ASA does not support wildcards. So anytime you are defining an ACL or you're trying to define a network to broadcast within a routing protocol, you need to use subnet mask. Okay, that's like a fairly big difference. Okay. The last thing that we'll cover for today is the ASA. So I've been going over ACL, right? It's the same thing, which you have been very accustomed to if you have been doing it on switch or router. Okay, it's basically how you do access control. Okay, you can have permit statements, you can have defines, nice statements, etc. And every single interface on the ASA can have an ACL in direction or in out direction. Okay, the best practice is to use ACLs in direction always. Okay, and there are 3 different types of ACLs or 3 different ways in which you can do ACLs. One is your control plane ACL. Okay, another one is a regular ACL. And then you also have a global ACL. Okay, and they are preferred or matched in a top-down manner. Okay, so if we look at when we said that, hey, we can create an explicit ACL to allow ICMP. Okay, the way that you would define that is first you'll create the ACL, which would be access list, give it a name, can be anything. Okay, permit ICMP any. Obviously, there's a source and destination. You can fiddle with it. Once you have defined the access list, you then need to apply it to the interface. And just like on a router, you do it through access group. Okay, so access group, the name of the ACL, you then give it the direction and the interface name. Okay, so this part is create, this part is apply. Okay, so it's kind of like very similar to um, a router, but on the router, you do the access group on the interface itself. Here you do it globally in the global config. Okay, so you first create the ACL and then you apply it. And like I said, the general recommendation is to, or the best practice recommendation is to do ACLs in or always in the in direction. Okay. Any questions? Okay. All right. So we'll end it for today. Okay. So first two classes, they were 1 hour each. From next week, we're going to do our extended 2.5, 3 hour classes, the way that I discussed yesterday. Okay. So we'll end this day. Next class onward, we're going to dive into the lab part. We're going to see how a lot of these concepts, they tie together. And then we're going to look at some more advanced topics after that with respect to traffic flow, NAT specifically. Okay. So if there are no questions, then we'll end it for today. Okay. Have a good rest of the week. Thank you. Bye.